As you said, my name is Andrew Clark. I'm a front-end engineer. I've been creating React apps for about 2 years now. Many people don't know this, but I am one of the co-creators of Redux along with Dan Abramov, of course. Yep. I also created a library called Recompose. Are there any Recompose users out there? I know I met a few earlier. Cool, awesome. If you want to talk to me about that later, that'd be sweet. And I also recently joined Facebook, which is really cool. I just joined last week, though, so I can't really give you any secrets yet. But I'm going to be on the React team, and I'm very excited about that. So today I'm going to be talking about something called React Fiber. And I must admit, I was a little nervous about this topic for a few reasons. One is it's highly experimental. So it's not something you can use today or really anytime soon. It's possible that this experiment will fail and you'll never get to use it. Even if it does work out, it's going to be like a few months at the very least before you can try it. And when it is released, if it's released, the whole idea is that you're not really going to notice, maybe except for your app will get faster, because really we're just going to try not to break stuff. And then lastly, it's a little nervous because I still only kind of barely understand how it works, but I'm going to give a talk about it anyway. Having said all of those caveats, I'm really excited to be here and to talk about Fiber, and I think you're going to enjoy learning more about it, because I've really enjoyed learning more about it over the last few months or so. So what is React Fiber? React Fiber is the next version of React. Appropriate given the name of this conference. So now when I say the next version of React, I don't mean like 16.0 whatever. I mean it's like a ground-up rewrite of React's core algorithm, of like the whole internals and how it works. And so, in my opinion, this is the most exciting thing that's happening in the React world, even though it's not going to be quite out there for a few more months. This is the thing I'm most excited about for like the near-term future of React. And I think a lot of the other members of the React team agree. If you saw Christopher Shadows Viju's React-to-Flex Q&A a few days ago, he said the same thing. So quick show of hands, how many of you have actually heard of React Fiber before? I just said it right now. So okay, a few like scattered hands. So if you raise your hand, it may be because you heard whispers about Fiber on GitHub or Twitter, passing references to some new version of React every once in a while, maybe a new reconciler, a new core algorithm, things like that. So that's how I first heard about it too. That's because there is no real official documentation on describing what Fiber is. You may have come across a document that I wrote called React Fiber Architecture. I put on my GitHub about a month ago, I think. And that got some eyeballs, but that's not an official document. That's an outsider just trying to make sense of something that's really exciting, but still was a little opaque to me. And it remains undocumented because, as I said, it's still highly experimental. And I've said that twice because I'm trying to impress upon you that it is highly experimental, so consider yourself warned. Yeah, so just a little bit of history. The React team has actually been working on Fiber for for a while now, and even before it was called React Fiber. So I did a little digging recently. Here's a tweet I recently rediscovered. I read this back when it was originally tweeted, and then rediscovered it as I was preparing for this talk. And it's Jordan Walk, who's the inventor of React, if you didn't know this, and some of the other core team members teasing here some new version of React that they're working on. And notice this was written in August of 2014. That's over 2 years ago. And it turns out that since the time that tweet was posted, the React team has worked on a lot of experiments and research and prototypes of some new version of React that could do a lot of the things that that are listed here in this kind of thread. And Fiber is just the latest iteration in this series of experiments. But what makes this particular experiment different is that there are actual commits right now being made to Fiber in the GitHub project that you can follow along in. So it's getting closer to something that'll actually be real. And I said it's experimental, even if this version maybe doesn't make it out. Something like it is. So that's why I don't feel too guilty showing you something that as of right now is not totally completed. But yeah, you can totally go onto GitHub right now and follow along as it's being implemented. That's how I learned pretty much everything I'm about to tell you right now. So I have a few goals in this talk today. I'm going to talk like why Fiber exists, why are we rewriting React. That's one kind of point I want to talk about. I want to talk about how Fiber works a little bit, like in terms of its implementation. And then I'm going to talk about what types of features and cool things this is going to unlock. 'Cause there's just some really ambitious stuff that, that Fiber is going to let React do. Mostly, though, I just want to get you really pumped for React Fiber. I'm like really excited about it, as hopefully you can tell. And if I can get you guys excited about it, or all of y'all excited about it, then I'm going to consider the talk a success. So okay, so first, why rewrite React? So there are a few reasons. We're going to start first with a topic called scheduling. So scheduling, it's a term that can mean different things in different contexts in the world of computing, but it's the process of determining when work should be performed, essentially. When I say work, I mean just any kind of computation. In the context of React, that's work we'll refer to like reconciliation, virtual DOM diffing, and just rendering. That's what work is. So scheduling in the context of React, what does that mean? Well, a central idea in React is that UIs are expressed declaratively, of course. So rather than having to imperatively mutate the DOM, you can return a description of your UI for a given set of data, right? That's the core premise of React. And that means you don't have to worry about how to efficiently transition your app from one state to another, from A to B, B to C, C to B, X to G, whatever. React just takes care of all that for you. So this leads to some really big wins in how we structure our apps. I'm not going to dwell on this too much. This is an advanced talk. Everyone here has used React before, I hope. So I'm not going to dwell on this. We all know that components are awesome to work with. But aside from being a better paradigm for developers, this declarative nature of React gives a really nice feature of this declarative nature of React is that it gives React control of scheduling. React gets to not only decide how to update your UI, but also when to update it. So to put this in a little bit more concrete terms, what that means is when you call setState, the contract of setState is not so much you telling React, hey, render this component now. I mean, in effect, that's what happens. But that's not really the contract of setState. It's more like saying, hey, this component has changed. Do what you need to do to update the UI whenever you think is best. That's a little bit like a more accurate way to think of setState. If you ever heard the terms push versus pull, that's what this idea is referring to. A push-based approach requires the app, by which I mean you, the programmer, to decide how to schedule the work, how to decide when to perform certain types of work and when to not. A pull-based approach is when the framework, React in this case, it's when the framework is allowed to be smart and make those scheduling decisions for you. So React is a pull-based paradigm rather than a push. An example of a push-based paradigm would be any of these like FRP-style UI libraries like Cycle, for instance. So what's special about this idea? For one, it gives React the ability to prioritize different kinds of work. So let's think about what we mean by that. Think about the different ways that updates, re-renders in a React app can be triggered. So there's user events, as in like clicks or like a form input change. There's external data subscriptions via like Redux or Relay or MobX or anything like that. And then there's animations, for instance. So this is an element transitioning from one thing to another. Perhaps you're performing some sort of gesture and you want to animate that and make it look really nice. Now, because the current version of React doesn't really take advantage of scheduling in any big way, all these different types of re-renders that are triggered by these different types of things are treated exactly the same, essentially. When setState is called on any component, that component and its entire subtree are recursively re-rendered synchronously until there's just nothing left to render. But if you control scheduling, what that allows you to do is give higher priority to some types of work over others. So for example, if you have two pending updates that need to render, and one is an update that is triggered by new data in a Redux store, for instance, or in your Redux store, for instance, and the other one is a re-render caused by an animation that's happening 60 frames a second. and you have these two updates that you need to render. Which one should come first? Which one is more important to render quickly and first? The Redux store update or the animation? So the answer is the animation, because if an animation drops frames, that leads to a bad user experience. Whereas if it takes one extra frame for your new data from the Redux store to appear on the screen, no one's going to notice that. That's going to be imperceptible. But dropped frames, people notice that pretty easily. That leads to a bad user experience. So keeping your animations fluid is really important. This might seem counterintuitive, of course. You might be tempted to think, well, Redux data is more important than, that's the important information. The animations are just visual fluff. But in terms of user experience, a janky animation is much worse than just like an imperceptible delay of when data appears on the screen. So essentially, without scheduling, all updates are going to be treated equally, applied immediately, regardless of their priority. You're just going to apply them all at once. With scheduling, different updates have different priorities. So here's another example of when this is important. When you update a component and it's not currently visible on the screen, how efficient is that? Not very efficient, right? Like, it doesn't make sense if the component's not even on the screen to immediately start rendering it. So this issue comes up whenever you're dealing with list views, right? This is a very typical situation people get themselves into. If you have like 1,000 items in a list, so this is just, oh shoot, sorry. This is, how did I get there? Okay, I don't know why this isn't playing, but, oh, there we go. So if you have 1,000, this is just a movie of React Virtualized, if you guys have heard of that. It's a pretty cool virtualization library for React. If you have 1,000 items in a list and you don't want to account, and you don't do anything to account for all of the items that are off the screen and the list re-renders, then you're doing a bunch of wasteful work and your app's responsiveness will really suffer. So one thing you can do to help with this is deprioritize any of the items that you know are off screen until after the on-screen work is done, and that will prevent some jankiness. So React Virtualized actually doesn't do this. It does something called windowing, where it just doesn't render items if they're too far off screen, which is, that's also something you want to do, and it's something that Fiber will actually help with as well, and we'll talk about that later. But this is one example of where you definitely want to deprioritize off-screen content. And if you have a scheduler that can prioritize different types of work, then it's something you can do. So now I'm going to show you an example. You got a little peek of it when I made a mistake earlier, but I'm going to show you an example now of Fiber and how this prioritization concept comes into play. Now, as I said like 5 times already, Fiber is still very new. So this demo might seem like weird, like why are you showing me this weird triangle demo, Andrew? But this is kind of, hopefully I can communicate to you like what this demo is trying to show. So, is it playing? Okay, so let me explain this. It's a little weird. So we have this giant triangle, and each one of these blue dots is a React component. Some things to know about this demo, because it's a little bit contrived, because no one's going to build an app like this. I mean, it does look cool, but no one's going to build this app. One of the things that you should know is that in the render method of each one of these little dots is a giant while loop that iterates through like, I don't know, like 100,000 iterations, just completely wastefully, just to simulate like a really expensive render. So that's one thing to know. Another thing to know is if you notice every second there's a number on those dots that's incrementing. Essentially every second the entire tree needs to re-render so that we can get the new numbers on those dots. And then the other thing you need to know is you can notice that the entire triangle is shrinking and expanding just constantly on every frame. So the way we're doing that is on every single frame, 60 frames per second using a request animation frame, we're re-rendering the topmost container and just setting a CSS transform to like scale the container so it shrinks and expands. And since it's the container, and because with React, as you learned from Boris's talk, if you were here for that, when you re-render a container, all of its children also update. So essentially, on every single frame, we're calling render on the topmost component, which of course triggers the entire thing to re-render. So you can imagine like rendering all of these components and knowing that the render is really expensive because we did that crazy like 1,000 wasteful loops thing. If you're not careful, this can be really bad. Fortunately, we're using Fiber here with prioritization and scheduling, so it actually works really well. It's a little bit of jank, but that's just the video. It looks very smooth if you look at it on the computer. I'm going to give you a peek of what this looks like if you don't use scheduling, and that's this. So here, you can notice it's not expanding and contracting anymore. The numbers are just totally frozen. These colors I forgot to explain, that's a visualization of the reconciliation going on. It's not even getting down to like halfway through the entire tree. Oh, that's me making a mistake with the recording. But it's not even getting down like all the way to the bottom of the tree because it's trying to re-render like every frame. And because there's no concept of like deferring work, it's like getting stuck trying to get all the way down the tree before the next update comes in, and it ends up wasting a lot of work. Whereas in the Fiber version from before, what we were saying is deprioritize everything except for the topmost animation where you shrink and contract, get to that other stuff later, and just prioritize that fluid animation, because that's a lot more important than the every second tick thing. So if that didn't make sense, hopefully it will a little bit better in a bit. It's hard to explain in words, but we'll get into more of the nitty-gritty. So related to scheduling is this concept called concurrency. And this really gets to the heart of Fiber and what makes it so powerful. Now notice I didn't say parallelism, I said concurrency. This is all still happening in a single thread. So let's talk about what this means. So remember that in the current version of React, as we just discussed with this that triangle demo, a call to set state causes an entire subtree to re-render, synchronously and without interruption, essentially. There's some batching, but for all intents and purposes, it's synchronously and without interruption. But what happens if you're rendering something during an animation, right? And you're between two frames. So typically there are 60 frames in a second, as we said, so about 16 milliseconds. Every 16 milliseconds, an animation needs to fire. But say when that deadline comes, you're still busy rendering some lower priority work. So it's time for a new animation frame, but you're busy rendering something that's not all that important, like something that's off screen, for instance. In order to do prioritization and scheduling right, we need some way to be doing that lower priority work and then interrupt it. Perform the higher priority work, and then come back to the interrupted work and resume rendering so that it doesn't just stop completely. That sounds pretty tricky, right? How do you interrupt a rendering component? So let's think of this way. So it's not really a React presentation until someone throws some version of this formula up on a slide. Conceptually, of course, we think of React components as functions of data. And a tree of React components is just some nested function calls. And rendering a component is like calling a function. So in this conceptual analogy, which is going to be really important as we move forward, components are functions, what we're attempting to do is interrupt a function call. Remember, we're trying to pause a component rendering. That's, in our analogy, that's like interrupting a function call. So how do you interrupt a function call in JavaScript? Can anyone think of a way? Did someone say generators? Yeah. So yeah, generators. JavaScript does have generators, and you can interrupt them. And in fact, generators are used, I think a lot of people know this, generators are used to implement like concurrency primitives. Has anyone used co or anything like that? Or Bluebird spawn, I think is what it is. So yeah, generators do exist. It's not quite what we're looking for here. I'm not going to explain why, but that is one way that you can implement concurrency in JavaScript. How about this? If I throw a debugger statement, that'll interrupt the function, right? I'm going somewhere with this, by the way. So yeah, if you drop a debugger statement in your function, or you create a breakpoint in the dev tools, it's going to pause the function execution. Just keep with me. And so if you do this, you'll see a view like this. This is the call stack on the left, where each frame's return address points to the frame below it. And then on the right is some information about the current stack frame scope. And there's that blue button, and then when we click the blue button, the function continues executing. So obviously, we can't use debugger statements to implement concurrency in our UIs, but I'm using this example to illustrate that this is basically what we're trying to do, right? We're trying to pause a function's execution or a component from rendering, and then resume it later when we feel like it. So that's essentially what we're trying to do. It's actually a little bit more complicated than that. It's a little bit fancier. What we really want to do is we want to interrupt the current rendering call stack. want to stash that call stack over to the side somewhere, just put it over somewhere for later, like save it. Then we want to we have some higher priority work that we need to do, so go do that higher priority work, which has its own call stack, and go all the way through it. And then once that higher priority work is done, like an animation is done, go back to the original call stack, and then keep going from where you stopped before. Okay, so this might sound pretty crazy, but this is essentially what React Fiber does. It pauses work, completes some other work, then continues later. Except in my little example, we were only switching back between two things. Fiber can switch between, limitless numbers of things. There's no limit to how many call stacks it can be working on at any moment. So that's what Fiber is in some sense. It's a re-implementation of the stack, specialized for React components. You can think of an individual fiber as a virtual stack frame, if that helps, where information from the stack is preserved in memory on the heap. And because the stack frames are preserved on the heap, you can manipulate them as data structures and execute them however you want. And you might imagine that when you control the stack like that, you can implement all sorts of clever concurrency features on top of it. So that's another way to think about fibers, is that they are a unit of concurrency. So just as an aside, if some of this is, if you're having trouble grasping what this is, if you're not familiar really with call stacks or something like that, don't feel bad. I myself barely understand it. Fibers are really a language level concept. They're a much lower level abstraction than UI developers typically think about. Fibers in React are heavily based on fibers in OCaml, actually, where they're used to implement sophisticated features in that language, sophisticated concurrency features in that language, such as algebraic effects, if you know what those are. So this is really language level stuff. So don't feel upset if you don't totally grasp it immediately. So here's a table I made to kind of compare a stack frame to a fiber and see how they're similar. So in a stack frame, every stack frame corresponds to some subroutine or function. In a fiber, the conceptual analogy would be a fiber has a component type, right? And that's kind of like a component is a function. In a stack frame, you have the body of the subroutine, which can contain some nested function calls. In Fiber, those nested function calls, the analogy is just children, essentially. A stack frame has a return address so that the program knows where to return after the subroutine exits. For Fiber, that's essentially just your parent component, right? Whichever component comes above it in the tree. A stack frame will have arguments into that stack frame, into that function. And the analogy, of course, for a component, the input is props. And then stack frame has a return value, and Fiber have, eventually a React component corresponds to some resulting DOM output. So this is a little bit of a high-level overview. I'm not going to go too far into detail again, because the exact implementation details are surely going to change many times before Fiber is released. But this is just a general sense of how stack frames and fibers are very similar. But fibers also have some fields that are specific to React components and don't really have any analogs. For instance, there's priority, as we mentioned. Every stack frame has a number that indicates what the level of priority it should have relative to other kinds of work. It has a field that contains the memoized input. So this allows React to say, okay, so the input hasn't changed. I don't need to bother re-rendering this. I can just skip it. It has a key. So you know how React elements have a key? That's a really important when you're doing virtual DOM diffing or reconciliation, because the key, when you have a list of items, is what tells React at what position that item should be in the list. So to repeat, fibers are a unit of concurrency, and they allow us to break work into chunks. And this is really crucial for implementing the scheduling and the prioritization stuff that we discussed a little earlier. You can't prioritize work unless you break it into units. So there's another piece we need to do scheduling properly. We have a strategy for prioritization. Fiber has a method of assigning priority to different fibers. We have a way to break work down into units, because a fiber is going to be our unit of work. But we also need a way to determine when to actually perform that work, and when to yield to the event loop so that we can continue it later. So let me try and explain that a little bit more. So modern browsers give us two APIs for doing this, for scheduling work at the ideal times. Request animation frame and request idle callback. I think most people know what request animation frame does. It's called on every frame, typically like 60 frames per second. And we use that to schedule work that has like an animation level priority, like a really high priority. Of course, you can tell from the name, it's for animations. And then request idle callback. This one might be a little bit newer to some people. I think it's only implemented in like Chrome, maybe. I'm not sure. It's not. It doesn't have as much implementation in the browsers yet. But this is a really important API as well. It schedules a callback to be called during a browser's idle periods when it's not doing anything else that's important. And we use this to schedule all work that is lower than animation priority. So basically anything that's not animation, we schedule it using request idle callback. And the neat thing about request idle callback is it provides to that, when it calls the callback, it provides an API like as an argument. It provides a deadline API that lets the callback know how much time is left before the idle period is over. So you can imagine there's these idle periods every once in a while in the timeline of a browser. Request idle callback lets us know like when we're heading up to like the end of one of those idle periods. That way we can stop performing work, yield back to the event loop, and then we can just pick up later when the next idle callback begins. So yeah, this deadline is what lets React Fiber know, hey, let's pause rendering for a bit, see if there's anything else more important that we need to do, and we can continue later. So here's a very high fidelity visualization to show you kind of what this means. This is meant to illustrate how request animation frame and request idle callback allow us to yield between high priority work and low priority work. So say you have like 40 units of work, low priority work that you need to perform. Diagram on top shows that without yielding to the event loop, you're going to have to perform, like in the current model of React, you'd have to perform all of that work all at once because you have no way of interrupting it. You have to perform all that work at once before you can animate just a single frame, right? Whereas if you, on the bottom diagram, which is able to yield, then you can split that work into 4 chunks, and then you can still animate those frames in between. So in the top version, your animation is going to look really jaggy and awful. On the bottom version, we're still able to interrupt, we're still able to render these frames without like stopping the other work. It just happens a few frames later, but since it's low priority, it's no big deal, no one's going to notice. So now our animation is going to look much smoother, and we're going to have a much better user experience. So this is a bit simplistic, but it should communicate the basic idea. So as I said, some browsers don't implement request idle callback. We can kind of fake it. It's not going to be as good as a proper native version, because really only the browser vendors can tell us like when is an idle period and when is not. But it's, even our fake versions can be better than never yielding at all. Hopefully, the browser vendors will add this API fairly quickly. It's pretty important. So now I want to talk a little bit about some other features that, this is pretty cool in theory, some of this stuff, but I want to talk about some of the concrete features that, besides just making your app feel snappier, some of the concrete features that this concurrency stuff is going to enable. So there's one particular feature that I'm really excited about, and that is integrated layout. So this is not going to be in the initial release, but it's one of the goals that the React team had in mind when designing Fiber. I can't spend too much time on it, but the gist is essentially that Fiber has a new concurrency primitive used internally called coroutines. And coroutines allow this back and forth yielding between child and parent components. They're not a user-facing feature, but they're going to be used internally by React to implement layout primitives, such as Flexbox or other types of layout algorithms that you can imagine. So a practical example for why that you would want to do this is, as we were discussing earlier, table virtualization. So table virtualization, that windowing algorithm, is a lot easier if you don't have to read from the DOM constantly, like how big certain elements are. As Boris, if you saw his talk before mine, as he was describing, reads can be very slow. If we control the layout information ourselves, that just removes an entire reason to ever have to read from the DOM. And so React can figure out which items in a list should be rendered for a given scroll position. And this opens up a lot of doors. Controlling the layout opens up a lot of doors to features that weren't previously feasible, and it's only really possible by having this ability to have concurrency. So, okay, so this may sound crazy to have React kind of take over the layout for the elements on your page, but keep in mind that React Native is already kind of doing this it has its own implementation of CSS Flexbox, and it's been pretty successful. So I'd maybe keep an open mind if you're recoiling in horror at the thought that React's taking over yet another thing that the browser used to do. So I'm pretty excited about that. And then here's some other miscellaneous features that React Fiber is going to make possible. One is return multiple elements from render. It's a very oft-requested feature. This isn't really totally related to fibers or concurrency or anything like that. It just happens to be really difficult with React's current implementation. If Fiber takes a while to come out, I think the plan is just to implement this on top of React as it is today. But this is going to be nice because sometimes I think everyone's experienced this, where sometimes you want to return maybe multiple items in a table, but you got to wrap it in this div element or a span, and it's very unnecessary, and it just creates these junk elements that really do nothing scattered all over your app. And sometimes if you're using CSS or tables, that can mess with the layout, or Flexbox even, that can mess with the layout in unpleasing ways. So this is going to reduce the number of unnecessary wrapper elements in your app, and especially if this integrated layout thing becomes a thing, it's going to really reduce the number of divs and things that you need. Because think about how many divs in your app exist solely for the purpose of just providing a layout container, right? If React controlled the layout itself, then you wouldn't have to use these empty divs all over the place that do nothing except for give something width. So that'll be pretty cool. And then, another another nice thing about Fiber is just because it's a rewrite, it gives us a chance to clean up the code base, hopefully make contributions easier, and just fix some things that that can be fixed now with the benefit of hindsight. Yeah, and it also just gives us the opportunity to just for the code to be a little bit cleaner. All the new Fiber stuff uses flow types, for instance, and hopefully this will make contributions a lot easier. So as we wrap up, perhaps you're still unsure what the point of all this stuff is. And if I had to summarize it in one slide, it's this. The ultimate goal is web apps that render at 60 frames per second, that feel just as smooth and as seamless as a native app. So to put this in a little perspective, most of you have in your pockets right now a supercomputer, right? So to paraphrase something that Tom Ochino once said to me, why is it that our smartphones can render a trillion billion polygons when you're playing some video game, but it can't scroll through an expletive list without stuttering? I cleaned that up a little bit. But the hope is that React Fiber will move us closer to solving these problems, and we can start building apps more on the web and kind of reclaim a little bit of territory from the war that so far native is clearly winning in terms of mobile app experience. So I'm going to close with a few more thoughts. To repeat, Fiber is highly experimental. I think I've said that 10 times now. But if it's released, it's not going to be for several more months. Some version of this will eventually see the light of day. It might not be Fiber, but these are things that are very important to the React team and to Facebook. So even if Fiber itself in its current form doesn't eventually become released, something like this will. Another point, the current Fiber effort is being led by Sebastian Markbage. I'm sorry, Sebastian, for butchering your name. I don't actually know how to pronounce it. And it's based heavily on a prototype by Jordan Walk, who, as I said, is kind of the father of React. He invented React. Plus the work of a lot of other smart people at Facebook over the years. I think Lee Byron, I think Pete Hunt. I'm going to forget everybody, but there's just a ton of people at Facebook have worked on this stuff over the years, experimenting and trying new ideas. And Fiber is based on all of those previous efforts. Another point, as I think I said this earlier, the first version probably isn't going to introduce any new features. The focus is just getting on feature parity. Because this is a total rewrite, we really just don't want to break your existing apps in subtle ways. So that's going to be the first focus. Another point, I talked a lot about prioritization earlier. The idea is not that you will specify the priority of things, at least at first. If we do expose prioritization at all, it'll be in terms of some higher level API. The idea is that we want React to handle prioritization for you just intelligently. So for instance, if an element has style display none, we can just infer that that element is off screen or whatever. So we can just give that really, really, really low priority. And then like on the other end of the spectrum, if it's an update is triggered as the result of like typing the letter T, like a keyboard press, that's something that probably needs to show up on the screen really quickly in order to have a pleasing user experience. So that'll give a really high priority. So the idea is to keep the prioritization stuff like as an implementation detail so that users don't have to think about it. Another point is follow along on GitHub. As I mentioned, I recently joined Facebook. I will be on the React team after I'm out of boot camp. But this talk I wrote almost completely before I was even talking to Facebook about joining. So this is all like stuff from essentially an outsider's perspective. And I learned it just by like going through the GitHub commits. They're like really detailed. Sebastian does a really good job, I think, of documenting his work as he goes along. And there's some really interesting insights in there. I've learned a ton just by reading through it. I'm actually not someone who has previously contributed a ton to React except for like community stuff and also like some little tiny cleanup PRs here and there. But I was able to submit some PRs to Fiber recently with a lot of help from Sebastian, which were recently merged, which I'm pretty excited about because they're like kind of my first non-trivial contributions to React. And honestly, I think there's no reason why a lot of people can't do that. I think Fiber is probably a good opportunity, especially as it gets a little bit more complete and closer to releasing, for like new contributors to join, to start making contributions to React, just because it's a new thing. You don't have to go through and decipher all of the crazy kind of technical debt or kind of the confusing parts of the React code base right now. It's a kind of a fresh beginning and perfect for you to dig your claws into. So yes, I think that brings me to the end. I was really worried I'd go over, but it looks like I have 7 minutes left. So if there are any questions, I would love to answer them if I can. Yeah.
Hey there. First of all, I think Fiber is a great feature, and I hope that it is going to happen. And second, is there any recommendations like how do we need to organize our code base in order to allow React in future to perform such optimization more efficiently?
Okay, yeah, that's a good question. So if I understand the question, is there anything we should be doing in our React apps now to ensure that it's ready for Fiber when it comes out? So as I said, like ideally, for most apps, it'll just work. But there are some things, especially related to lifecycle hooks, where it might be tricky. For instance, it's possible that some apps rely on the fact that right now when you call set state, it kind of synchronously updates the child components. In the future, set state's going to be a lot more asynchronous. You're not going to be able to depend on when that thing is going to get called. Another example is some of these lifecycle hooks might get called because you can abort work and pause work, and like it's possible that, for instance, like component will receive props will be called, but the thing will never actually render. It's very possible. I know I've written code before that relies on the assumption that component will receive props will always result, or component will mount, sorry, will always result in a render. So that's another subtle thing that might break. So there are some like weird edge cases. In general, like if you're following the docs and you're not doing anything like too outside the lines, hopefully the idea is that everything will just work. But if you're doing anything that's kind of considered an anti-pattern, it's possible that your app could break. Any other questions? We have like 5 minutes left, but we can just go to lunch too.
Hey, I'm not sure if you can answer this question, but it looks to me that the community gets to the age of dealing with the limitations of the language and the browser. It looks like the community putting puts a lot of effort in dealing with the things, like the lack of threading and all the things. Do you know if there are some, I don't know, improvements to the browsers that are coming out, or to the language or something?
Yeah, so this is really not I'm really probably not the right person to answer this. This is like a Sebastian question. So again, with the caveat that I don't know what I'm talking about right now, I think there is like lots of constant communication with the browser vendors. I think one of the desires is that for the browser vendors to like expose more low-level APIs. Sometimes like there's this tension between like, is the browser a platform for building apps, or is it like a target for platforms to be written on top of? So like React clearly like wants a lot of low-level access to things. So for instance, like in order to do this integrated layout stuff, one thing that'll be really important for that is having a reliable way to do text measurement, right? Because if we don't have a way to measure text, then how are we going to be able to determine the size of elements or divs or whatever? So that's an example of like a low-level feature that isn't really elegantly exposed by the browser right now that React needs. I'm trying to think of another example. I mean, request auto callback is another thing where like some of the browser vendors just haven't implemented that yet, but that's really important if you want to build nice scheduling for your UI library. So yeah, again, I'm not qualified to answer this question fully and completely, but hopefully that gives you like some idea of the kind of the tension there.
Hey. Sorry. Hey. When talking about fibers and animations, it seems like fibers brings to the table features to make it easier for React to performantly do animations. Does fibers also supply anything that makes it easier either for developers or for library authors to author animations? Because right now there's React Motion and there's a whole lot of other things, but it's relatively difficult to pull it off. Are there like better APIs coming down the pipeline in that sense?
Yeah, I actually don't know. I think so with all these things, I think the effort at first is just to get the right primitives in place, and then the user-facing APIs will come later. I don't know of any specific plans to. If I had to guess, I'd say I doubt that React will ever supply. Well, I don't know, maybe, because like React Native has animation APIs. If that stuff comes later, like a higher level API for animation, it'll be like it'll be further down the road. The initial focus is just getting the primitives right so that either a third-party library can write these things like React Motion or whatever. Because I mean, React Motion is pretty cool, but it'd be even cooler if it could do some of that prioritization stuff. So maybe it might just be like a way to like some high-level API to expose some of those prioritization features rather than a full-fledged like animation library or animation API. So hopefully that answers a little bit of your question. Yep. Oh, this will be the last question. Yeah, you can go, but this will be the last.
A short question.
Yeah.
The question is short. I'm not sure the answer. Why not generators? Why you?
Why not generators? So again, I'm probably not the best person to answer this question. So one downside of generators is that I'm not the right person to answer. One downside of generators, though, is that like you have to, if you have like nested generators or like a function set, you have to like manually yield. You have to like manually yield at every single level. You know.
It's a control thing.
Yeah, it's like a control thing. You probably could implement something like Fiber on generators, but if you look at the source code for Fiber, it's essentially like a bunch of while loops. Oh, that's the alarm. But yeah, I'm probably not the best person to answer that, but it just doesn't give the right amount of control for such a low-level thing. Hope that answer isn't too bad, but.